Hi everybody, welcome to one more of Mrs. John's lesson. This is for year 13 physics and it's under linear motion and concentrating on vertical circles. And today's lesson is about the feeling of weight. Why is it that sometimes you feel heavier? Why is it sometimes you feel lighter than you actually are? And why is it that sometimes you feel weightless? Now, all this has to do with the size of the reaction force. So if you're standing on a set of scales, your gravity force is acting downwards and there's a reaction force from the scales itself acting upwards. Okay, so I have over here a series of diagrams which represents traveling on a lift, and in the first one the lift is stationary. So when the lift is stationary, there are two forces acting. At all times there's two forces acting. So one is the force of gravity downwards. So the force of gravity downwards is the same the whole time. So this green arrow pointing vertically down represents the force of gravity. And I've got a vertical circle here, and I'm just going to do Fg the same the whole time, acting vertically down. Now, what does change is the size of the reaction force. And let's look at how does the size of the reaction force change depending on what's happening. So when it's stationary or traveling at constant speed, it's not accelerating, so the forces are balanced, and here the size of the reaction force that acts upwards will be equal to the gravity force, and you're going to feel normal. So in this one, Fr equals Fg, and this one too, Fr equals Fg, and in both those cases you feel normal. You don't feel heavier, neither do you feel lighter. Okay, now in this one here, the lift is accelerating downwards. If it's accelerating downwards, then the unbalanced force is always in the direction of acceleration. So the unbalanced force is acting downwards, which means our forces are no longer balanced, and the force downwards is bigger than the force upwards. Your upward force is your reaction force. So the size of the reaction force is quite small compared to the size of the gravity force. So in this one, your reaction force is smaller to gravity force, and what's going to happen is, because the reaction force is smaller, you are going to feel lighter than you usually are. Okay, so this is accelerating down. On the other hand, what happens if the lift is accelerating upwards? If it's accelerating upwards, then the size of the reaction force is bigger than the size of the gravity force. So when reaction force is bigger than gravity force, you are going to feel heavier. Okay, and this one is, it's like free fall. So if, like for example, if you went to Rainbow's End and you sat on the fear fall, where you go up to a height and you just drop down. So when you're just dropping down, there is no support force, so it's almost like the lift just falling down. When the size of the acceleration is same as gravity force, so there's nothing to support you up. You kind of almost lifted off your seat as you're coming down the fear fall. So that's when you feel weightless. So when your reaction force is zero, then that's when you feel weightless. Okay, now let's just bring this to circular motion, vertical circles, what we've been learning with. So, and you know, the resultant force always acts towards the center of the circle. And so at the bottom of the circle, when your resultant force is towards the center of the circle, your gravity force and reaction force are opposite each other. So your reaction force is much bigger than gravity force, because your centripetal force is Fr minus Fg. Okay, just turn this so that you can see that. Okay, there we go. All right, and so you're going to feel heavier at the bottom of the circle. Now at the top of the circle, both the reaction force and the gravity force are acting downwards, and the reaction force can be such that it's zero. So you could either feel weightless at the critical speed, or if you're going faster, you still feel lighter as compared to the bottom of the circle. Okay, because at the top, your centripetal force is reaction force plus gravity force. Okay, you just need to remember these two. Okay, because they're in the same direction, you add them. Because they're opposite each other, you add them vectorially, but because they're opposite, you find the difference. Okay, so I hope that made sense. Bye for now.